this talk like a year ago, and it was part of me trying to improve things at work. You know how that goes. And you're trying to like present it to your company, and you're trying to make things better. And how do you do that? So it's been a while since I've addressed this. So feel free to ask any questions. And yeah, so I'll go ahead and kind of jump into it. So yeah, I've been doing programming in Go now for a little over 3 years. Been enjoying it the entire time. I don't regret it at all until it comes to errors. And then I regret it a little bit. But yeah, so I'm gonna jump into this. Gonna be talking about OpenTracing today. And you're right, sharing the screen is always weird. Let's see. Let's see if that works. Does that work? Can people see my screen?
You're good.
Cool. Yeah. First time success. Good job, Zoom. All right. So go ahead and get started here. And yeah, feel free to pop in, ask questions, kind of, interrupt me at any point if I'm missing something, or if somebody knows more about OpenTracing than I do, feel free to toss in a little extra information. So OpenTracing is standard tomorrow. What is OpenTracing? Everybody knows about logging. We all log stuff. We all have massive log files, or we go to Datadog, or we go to whatever tool we use, whatever it is. But now that's fine if you have a monolith. If you have a single application and you just have your logs running from that application, logging tends to be enough. You don't need much more. But now what happens if you have multiple microservices running and something breaks in one and it affects some call further up the line? So let's say we have our user service, right? And in our user service, we're gonna make a user. And making the user in the user service, simple thing, you're just gonna insert your user in a database. But then you also wanna maybe send them a notification saying, hey, thanks for joining JFrog, thanks for joining Datadog, whatever. And you wanna send them an email about that and just say, welcome to the service. And then say, we're also dealing with money. So we wanna initialize kind of like a payment account for them, maybe set them up with initial like Google Pay stuff, or maybe whatever. We got to start that off and say in that payment processing, we're not processing the payment yet. We're just kind of setting up their account. We do some stuff in there, and maybe that do something just failed. It failed for some reason, and going through logs of like 3 different services can sometimes be a pain. Maybe you're not easily able to see how long something took in your logs. So this is kind of where OpenTracing can be helpful. It can be useful. I wouldn't say it's good to trace everything. I guess a good rule of thumb for tracing would be trace things that take time. And we'll be going through some code in a little bit, but overall, I'd say like if you're doing some stuff in the database and maybe it's a little more complex than a simple insert, maybe you want to trace that. Maybe you're making a call to some third-party API. And you want to know how long that API call is taking, or a bunch of other things. Maybe you're doing some stuff with Kafka, maybe whatever. Anything that takes time is a good opportunity to trace something. There's additional logging and stuff like that you can do. We'll get into that. And again, this is just an intro to OpenTracing, so I'm not going to be taking some deep dives in anything complex. This is just kind of to introduce it to people. You can see what it's about, and maybe you want to tinker with it too. So a couple of things to note. There is a start and a stop. We'll go over what a span is and all that kind of stuff in a little bit. But when you're logging, typically you just log a line. You just say, log this information, whatever it happens to be. But spanning, again, like I said, you want to trace things that take time. You have to wrap the thing that takes time. And we'll get into how that looks like in Go code in a little bit. And tagging, say we want to make certain aspects of some of our traces queryable. And we'll look into that in a little bit. Tagging really is just a way to say like it's indexed values, so you can look them up later more quickly. And logging, there's some logging you can do within your span. I wouldn't use tracing as a logging alternative, but you can add some helpful information in there so that you can add some context to your span. So yeah, some tracing systems that can be used, and you'll see how this affects the application in a bit. But there's Jaeger, Datadog, Lightstep, Instana. There's a bunch of them. Jaeger is the one I'll be using today just because it's super simple to set up locally. If you want in production, you can have Jaeger locally, and then maybe have some, stuff in your code that maybe points to Datadog in production, something like that. You're not stuck to one or the other. You can do different things at different levels of your stack. So that's it for slides. All right, so hopefully you can still see my screen. We're gonna look at a simple thing here, and I'm not doing anything complex. This isn't about code structure. This isn't about how to structure multiple microservices or monorepo, none of that. So it's just really, really straightforward. So to begin, let's look at our import here. Some important things we need to look at in our import. There's this first block of OpenTracing packages. We'll be using those in a bit. And then you can have different clients. So like I said, I'm using the Jaeger client in this one. And then we'll be doing some configs and logging, and that's it. So we want to initialize our tracer. Actually, before I jump into that, let's get into the visual cool looking stuff to let you know this is just generally what OpenTracing is, or tracing in general. So here is our, Jaeger UI. We pop into Jaeger. Let's do, there we go. You can look at all of your services that you have running. So you could see like, you can see we have a notification service, a payment service, and a user service. And then there's this Jaeger query. So just to get this out of the way, it's always confusing when you pop in. This is kind of like your Tom of MySpace. This is always going to be here. It's basically tracing itself. So as you're using Jaeger, it's tracing itself, and it's just showing you, this is what's happening behind the scenes. You can dig into this and play with it more if you like. But yeah, we're not going to be digging too much into that. So let's say we want to look at our notification service traces, right? So now here's a really simple one of just notify, the notify endpoint. We can see there's a single span. So this bar of time here is just a span. It's something that took time. We have a couple of, these are just your standard tags that come along with it. There's some process information. We have a log here. So we notified somebody of something. We got a notification ID of 432. I'm just making stuff up as I go in this application, so it doesn't actually mean anything. So here we can see our notification, our notify request took 47 milliseconds. You can look at that here. And that's really it. And we got our notification ID of 432. So maybe that was a text message that we sent or an email, whatever. And this is some sort of confirmation ID. So this is a really simple example, but now, like I said, tracing's most helpful when it comes to multiple services. You got multiple things going on. So now we can see our user service is doing some stuff. Here's the span that goes across everything. It's kind of the beginning of it. And we want to create a user, right? We're creating our user in this call, and wrapped in that span is two other spans. So there's a span for a notification call and a span for our payment service. So this is when it actually leaves the user service and jumps into the notification service. So you can see all of this request is being put together in one spot for us, where we don't have to jump around from one service to another. It's just visualized there for us. So we can see that the call to the user service took 51, let me see, does that help if I zoom in a little? We can see that our create user call took 51 milliseconds. In that, there was a create user event that took 20 milliseconds. And that 20 milliseconds occurred within the 51 milliseconds. So it's happening inside of that. And then we see this guy, the notification service, is going beyond the time it took for the user create. That means there's some background stuff going on. We were able to respond to our create user call before the notification stuff finished, which is great. That means our services are working as they should. And concurrently to that, we have something going on in our payment service. Now, looks like something happened in our payment service here. We got a cool little exclamation. We see error equals true in our tags. And we can see we got an error code, darn that mod 5. And we'll see what that means in our code. So what's nice about this, being able to see that error, we can query for errors here. Let me see. So error is a tag. So all we need to do is error equals true. Find our traces. Oh wait, there's something else. Yeah, it should be error equals true. So what happened there was I was actually doing that query within the notification service. So let's pop over to the user service. Trace. So no errors in the user service. Let's look over at payments. There we go. Now we see all our errors that occurred within the payment service. So now if we were to look at that, we can see, something happened here. A little bit before that, same kind of error, darn that mod 5. So this is a nice way to just query our errors, look at what's breaking. And then what we can also do is, if we have a much more complex trace going on, we can pick 2 of these guys, and one has an error and one doesn't. We can compare our traces. We can look at, oops, nope, not that. We can see here, like, we're looking at our A trace and our B trace. So we'll get to this in a bit, but this kind of starts us off. I think what's happening is I'm not tagging with the error information. So we'll look at that in our code now that's going. So let's go back here. All right, so any questions at a high level about the UI? Maybe I missed something or anything like that. No?
So quick question.
Yeah.
The errors tag is actually really, really cool in terms of you get to see some kind of icon says something went wrong. Is this a predefined tag that you get, or is there a way you can configure it to do that?
Yeah, so the error tag is a predefined thing within Jaeger. So, and I'm guessing it's a thing across most tracing services as well, because they're all following this OpenTracing protocol. So I would assume that it's there for everything. I haven't played with it enough. Typically, I just use error equals true, because all I care about was, did it work or did it not work? So I haven't played more around with, can I make other things happen? There might be that flexibility, but I don't want to say for sure yes or no. But the error thing, to answer your question, is a built-in functionality. Yeah.
Cool. Thank you.
Yeah. All right, cool. So now we're going to pop over to the Go stuff. I kind of jumped ahead of myself at first. So a couple of important pieces here. We're looking at our main function here. One of the first things you want to do in your main, typically you'll initialize logging, you'll initialize your connections to your database. This is where you'll want to throw in initializing your tracer stuff. Is all in that setup and the prep that you're going to do with your application. So let's look at our initialized tracer. There's different ways to initialize this. This is just from pure configuration. You can also do from environment variables, and there's some predefined environment variables where it'll pull in most of this information. For this, I'm just using configuration, not trying to make this fancy, but we can see, no, not that. So some important things on here. So service name, user, that's just the name of the service. The sampler, this one's really cool. You can have different types of sampling. So you might not want to trace everything that happens. Maybe you want to trace some percentage of things that happen. So you can do sampler type probabilistic. And for this parameter, if we look at this guy, does it explain it here? It doesn't. All right. Well, it's going to be expecting for the param a float 32, I believe, and you're going to be passing in a decimal. So like 0.3 would be 30% of the time you're going to submit a trace. And that's really nice when you want to save money. And I think it's been a while since I've looked at these. Yeah, so here's another one. You can have a tag key. So this is another one where you can put in information. Maybe you want to just trace your errors. That would be something that you can throw in there is say, just trace my errors. Just trace anything where error equals 1. For this one, I'm gonna sample constantly. So it's 1 for true, 0 for false. So for this example, for what I'm doing here, I'm just tracing everything that comes through all of the services. And then this guy, reporter configuration, this is just what's reporting, what's happening. Not super important. I just have this set, log spans to true. This is for, if you look down here in the logging, I'm just logging that a span occurred. This is just for troubleshooting, stuff like that. You wouldn't necessarily want to do this in production. So here we go. You can pass in different loggers. So maybe you're using logris, whatever. I'm just using the Jaeger logger. Here we're initializing our tracer. And this is just, again, for debugging. I'm starting a span. I'm calling it test span. I'm passing in some keys, some val, and finish. So going back to that slide on, there's a start and a stop. Here's the start to this span. And that span doesn't actually get sent to our tracing service, which in our case is Jaeger, until the finish is called. So it initializes it, preps it. You can add additional logs. You can add additional tags. So let's say we want to set some tag. We could just do some tag with another some val, right? So you can do all this stuff and do more things here, and then nothing will be passed on to Jaeger. Nothing will call out until finish occurs. I don't know. Let's see. Yeah, it's an interface. So finish. What's happening in there is a go routine to actually call out to Jaeger and submit all this data. So that is happening concurrently behind the scenes. So you don't have to worry about waiting for this message being sent out to Jaeger to finish or anything like that. It's going to happen concurrently, which is great. You can do this 2 different ways. You can set a global tracer that you can pull down later at some future case, or you can just dependency inject this parent tracer, this top level tracer to everything else that's going on. For this one, just to make things easy, I'm just setting a global tracer, but it's important to know you can do it both ways. So now we've initialized, and again, super simple. We're in our user service here. I'm pulling down that global tracer that I just set. We're going to be extracting headers. So the way that we were seeing, let's get rid of this stuff. We were seeing this kind of thing happening here, where the user span led into the notification span and the payment span. What you actually do is you inject that context for the span for the tracer into your HTTP headers. And there's this nice little wrapper for it. So as this call comes in, as this API call /create comes in, it's going to immediately attempt to extract the span from the request coming in. If there is no span, what'll happen is We can look at that later at the notification level. But if there is no span, it just gives you an empty span with no parent context or anything like that. Say we want to do some stuff. We're sleeping for some random amount of milliseconds to 50 seconds. So we can see that's what this time is here. But now if this is your trace, if this is some production level code, and there's a bunch of stuff happening here, and if you're looking at user and there isn't useful information here to tell you about what's happening for this time, maybe that's something you want to trace. Maybe that's something you want to get additional context on. So you can, if we wanted to, we could wrap this functionality, this whatever's happening here in a trace, and then we can get more context around that. So now let's go down into actually making a child span. So now there's this part here. Make a chili span. That's great. Make a child span. Create a child span. So what happens here is you pass in this parent span. So right now we just called this server span, API span, whatever you want to call it, doesn't matter. So we're taking that span, telling it we're going to start a span, and we're telling it it is the child of server span. So that's how it knows that it exists within user create user. And now this one is called create user event. So that's this subsequent span within it, the child of the parent span. And we're going to defer that finish. So up here, we create one for the API call. And it's nice to do this for API requests, just very beginning of it, wrap it in the span. You can do this in a middleware just to avoid these 3 lines of code and doing that at the top of every handler. I just have it here just to be explicit. So yeah, that's something that you can just get immediate information about all of your API requests coming through. Let's see. So now we're going to call our notification service. We're going to say, hey, notify us about something. Let's see. So in this example, so I'm going to rebuild our user service here. And then we're going to call, where'd my tabs go? There we go. So let's go, not that one. So here's our create user request. So we're going to hit that, and good news, user got created. Let's go back over to Jaeger. Find traces for payment. Let's go to user event, find traces. So here we go. So this is the one that just happened at 4:38. So we can look at that. And if maybe you're looking at your application and you see something like this, where notification did something, and then right after that, payment does something, but these things aren't dependent on each other, this can help you identify things that you can make concurrent, that you can just wrap in a Go func or create additional Go routines wherever you need to. But this is a nice way to get this high level overview of things that are happening, and then see like, hey, you know what? We can make this run concurrently. We don't need these to happen synchronously. So now let's look at our code and just kind of quickly wrap this. So here's our call to our notification service. So we can be lazy here for presentation's sake and wrap that in a Go func. So now we're going to restart our user service. So this is what it looked like before that Go func. Then we're going to call user again. User got created. Let's refresh our traces. So here's the new one at 4:40. Now we can see these guys are happening concurrently now. We can see that we don't need, if we don't need these to run synchronously, awesome. And then we get this nice visualization of what is actually happening behind the scenes. So let's go back over here. And this is us just making our call to our notification service. And this is the important part here though, is injecting the tracer. Up here, we extracted the tracer from the incoming request. Here, we're gonna inject it into the outgoing request. So we've made our new request. There's our request. We're gonna inject it into the request header here. actually HTTP headers here. That's the part where we're telling it where to put it. And we're passing in that client span context. Now this can be the parent span, which is server span, or the child span or client span. It's best to use the narrowest span you have available. So typically you would have these things wrapped in functions, and you'd be kind of dependency injecting your spans as you go along, your parent span as you go along. So for this one, it makes sense to use client span. It's the one that's most immediately wrapping the work that we're doing that's going to take time. So now we're going to do this one in the background as a go routine, and then it's going to do this one immediately after this one begins. So now we can see again, we're injecting same information. We don't have to do anything special for separate injections. It's the same thing. And we're making our request. This one happens to be a post. And then we just respond back with our user created. So now let's look at that error that was happening. So let's create a user a couple more times. Let's go back to Jaeger, find some traces. So here we go, we got an error. This one just happened 424. It's happening in our payment service. We can see darn that mod 5. So what does that mean? What's darn that mod 5 mean? So let's look over at our payment service. It looks super similar to our setup for our user service. Here we are again, extracting the span from the request coming in. So that's how we know, where we're coming from. And then here we have some random number from 0 to 100. Mod 5, if it happens to be, mod 5, that's where we're getting darn that mod 5, right? So now we can, from that super high level from Jaeger, we could see errors were occasionally happening, and we immediately were able to tell that it was starting from the payment service. And if you've gone through logs of, multiple microservices and maybe some like deep nested services being called in your mesh, and it responds with an error. So of course that error propagates up. And so you're seeing error logs across all of your services, which sucks because that's not telling you a lot. You have to sit there and dig through each one. Okay, where did this error come from? Oh, the subsequent service. Okay, where did that error come from? Another subsequent service. So you're doing this dive, whereas with OpenTracing, you just get that from these visualizations automatically. And you can see, oh, an error occurred. Let's look at that span and get that information out of it. So yeah, I mean, at a super high level, I gave a really kind of simple explanation of what's happening here. Just kind of get yourself started into OpenTracing. Any questions now that I kind of went over a high level thing? Any questions about any specific part of it?
Feel free to unmute yourselves, or if you prefer to drop in the chat, please do that as well.
Yeah, I got my eye on the chat, so if you want to put it there, please free to.
And I'm also keeping track with the questions, for some socks. Bill Gray wants to keep you warm this winter with some of the Gotham Go socks. So go ahead and ask away.
Yeah, so I had a question about, if you're calling basically a microservice or something that's not actually in the program, how do you associate to a parental span something that might be going on in some other, like Go system that you've just like gRPC'd to or something? Do you send some sort of identifier?
Yeah, so I know for sure it works with gRPC, and there's other injection methods. I haven't done tracing with gRPC stuff. I've only done it with HTTP requests. But you can also, let's see, let's look at our injection. So simple answer, yes. There is a way to do it with gRPC on the injection to the request. So if we look here, yeah, no helpful information there. HTTP headers. Yeah, so kind of the fallback to this, actually, yeah, so it looks like it's only HTTP headers is the way that's natively supported. But what you can do is inject the binary data or a text map of the data, which is essentially like a JSON. So you can, maybe you're not doing a HTTP request, maybe you're passing data through Kafka or some sort of message bus or something like that. You can just extract the text map and then just pass that in as another parameter. And then when you extract from that, you can extract from a text map as well. So here we can see, and it's using those same constants here. So you can extract from a text map field, and maybe that's just an array of bytes. Actually, I think that would be an array of bytes for a string. I forget exactly how that comes out. But yeah, that's how you would do it through non HTTP requests, is just extract that text map or whatever and just kind of pass that through. And then I see there's a question here. Is it preferred to pass the span in the HTTP headers? The parent span? Yeah, I would say definitely use the HTTP header stuff for this. If you really wanted to, like I said, with the gRPC stuff, you can extract the text, what's it called? The text map for the tracer, and then inject that your own special way. You're perfectly allowed to do that. But I would definitely say for the HTTP stuff, what I've done on my own projects and at work is actually wrap. So here we can see we're making an HTTP request. We've actually wrapped our HTTP request stuff that happens with a really simple function, and all that's doing is the creation of a child span, injecting that, doing basically like these couple of lines, this line here, and then it'll check for some sort of parent span coming in. If it doesn't exist, it'll make its own. And then that way you're not having to worry about that couple of lines of code for everything that you're doing.
I have a question about, kind of over like 10,000 feet view. You did mention mesh and like typically service mesh like Istio. You get out of box, tracing and some telemetries and other logging, which you can kind of actually go back to some Jagger or some other kind of. So I'm just trying to put this thing together. Like, when would you actually? What's the real use case for this one? Like when you actually have to write code, or kind of as a whole leverage, out of box functionality from like service mesh, such as Istio. In other words, sorry, go ahead. Go ahead.
So correct me if I'm wrong. I haven't used Istio, but I'm pretty sure Istio wraps all like service-to-service calls within its own spans, right? It's kind of doing that a little bit for you. Is that right?
So I'm not quite familiar with the term span, but what I know, like there's the envoy.
Tracers, yeah.
So the envoy is going to be actually, so essentially there's a control plane and data plane basically is sidecar proxy, which sits right next to the microservice, intercepting all the traffic, and there's through the control plane, it would be doing tracing and all the whatever you kind of dictate as from a policy point of view, whatever you want to kind of watch per se, including logging and all 9 yards. So it comes out of the box where it goes through one of the control plane component and which is responsible for like a mixer or whatever. So my understanding is that the envoy is does all the magic, which sending all this, because it's intercepting all the traffic. It's also kind of sending that over to the other components of the service mesh, which eventually makes it to that. So that is my reading. And because it's an L7 compatible, so it because it's intercepting like HTTP traffic, it knows, like you were describing, the headers, so it can deal with that kind of stuff. I think it can also deal with gRPC and I think TCP stuff, and I think they also added Kafka to it So Envoy has smarts to deal with those. Yeah, sorry, go ahead.
Yeah, so it sounds like you have kind of like a out of the box solution from Istio that does a lot of tracing for you for inter-service communications, right? Which is nice when that's all you care about, and it gives you that very quickly, right? It's going to automatically do that if you have all of your stuff set up on Istio, you got that mesh set up. You're going to get some really simple tracing, but across everything that's happening. I would say it's still helpful to do it within your code to get more in-depth and more specific information about things that are happening. So say you have some like heavy reporting queries that are happening within some application. It's super helpful to trace that, to see how long on average does this reporting query take? Or maybe you're calling out to some third-party API. My company uses Sailthrough as an email service. It's ridiculously slow on registering a new user when you send in new user profile information. And if you're not specifically logging that, or you're not specifically tracing that, you just know that your requests are taking sometimes an extra 60 seconds for no apparent reason. So that's where tracing can be really helpful to get that really specific data, that really specific information about things that are happening behind the scenes.
Got it.
Yeah.
So yeah, I was kind of more interested in your experience. I think you have been using, what's your, best gain? Is it like from testing perspective that you found it more useful, or it's actually in production that, you actually have custom tracing, which saves you, a lot of troubleshooting or whatever. I mean, I'm just kind of curious, like what, in your own experience, what do you think is the best selling point for actually custom tracing? Like, do you actually have to write code for that?
Yeah, for sure. Yeah, so it's occasionally helpful locally in development and debugging. For the most part, when you're working on whatever set of services, you're probably only working on 2 or 3 services at a time. You don't have your entire production infrastructure built up on your local machine. So you don't have that level of confusion happening there, where there's 50 services that get involved in this one request, and you want to know what happened, because generally you're doing really specific stuff locally. It's in production where anything can happen, and you have everything running, your entire infrastructure running, and stuff happens. And that's why it's really nice to, it's kind of what I was talking about in initializing the tracer. When setting up the sampler, it's what we generally use in production is we sample about 10% of our requests. And what that means is that's 10% of initializing points for a trace. So in the setup that I have here, the initializing point would be this create user. That's that publicly exposed endpoint that's being called. And then that's subsequently calling payment and notification. So 10% of the calls to create user will get traced along with everything below that, because we're injecting the trace to our requests. So anything that starts with the trace, great, it's going to continue that trace. It's going to continue serving up information to it. But if a request comes in without a trace, then that's where that sample rate comes in, where it's like, okay, random number between 1 through 100. Great, it was less than 30 or whatever's happening behind the scenes on that. But it was, it's one of the 10% that gets traced. Great, it'll trace it. Otherwise, it won't. And that will give you, it's really simple, and that it's really dumb math. We're not doing anything more intelligent than that, because we still are logging everything, right? Everything important, we're still logging. The trace is there because we're going to get 10% of everything that happened. We're going to see 10% of the errors that happen, 10% of all the other calls that are happening. We can go back and we store this data for a couple of days, so that we can kind of quickly go back and see, this many errors occurred on this endpoint that weren't happening previously. And we can use the comparison tool. Didn't work for me in the setup right now just because I don't have those tags set up. But you add those tags, and then the comparison tool can then tell you what's different on the tags. So I would say it's more for production level stuff and kind of figuring out what crazy things are happening in your prod environment.
Got it. Thank you.
Yeah.
So I have a couple of questions.
Yeah.
So I was using OpenTelemetry, which has OpenTracing as the API. And I was using OpenTelemetry's SDK, right, to do the actual work. Mm-hmm. So we have our own reporter that we send things over to, right, something proprietary within work and whatnot. So the question I have is in terms of synchronization, right? So I know in other languages, there's some synchronization that the vendor does for you in terms of, let's say Java, right? Probably does like a thread local where it makes sure that, you know, certain threads don't bump into each other, don't accidentally bleed into each other and whatnot. I know there's a concept of context in Go. I was wondering if most vendors, especially OpenTelemetry, if they're using that. And my second part of the question is, what part of the synchronization would you think would be the responsibility of the application developers that are using these vendor products?
Oof. Okay, let's see. So the first one is kind of what other packages are using kind of that, maybe like the HTTP header that you're talking that you mentioned, yes. Right? I would hope that they are. I'm guessing it's because it is part of that protocol. It is part of that OpenTracing interface, if you will. So I would assume that they are. I've only ever done in-code tracing like this within Go. All of our services are with Go. We have some Elixir stuff. For that, we're using something similar to what whoever was asking the question earlier. We have like a higher level tracing product running in the background for service communication. So that was enough for that Elixir service because it wasn't doing anything crazy. It's just an old service that we haven't rewritten. So after that, I would assume that it does. But now for a language, say like PHP, right? PHP doesn't have native concurrency. I don't know if it would be a good idea to do open tracing within PHP because there isn't that simple concurrency. Like you mentioned, Java has threads that it can open up in the background. PHP, I know there's like P threads and some like weird stuff you can do in there for concurrency. I couldn't tell you what it would be doing in the background. So that might slow down your PHP requests. So I don't know. I would kind of pick and choose what languages would be good to use tracing on, to use open tracing on. Now the second part of your question, that comes down to whose responsibility is it to do, I forget.
So just to give you a little more background in there. So
yeah,
OpenTelemetry gives you a way of plugging in these different reporters. They call them exporters, but it's the same exact idea that you're able to open up some HTTP port over to some other place here. And then you usually create your own serializer to say, okay, I'm going to create a span pack. I'm going to have these kind of spans in there and, you know, whatever other information we have in that piece of it. So wondering if we would be responsible for serializing the serializer, synchronizing the serializer itself here, and when it's constructing the information, and possibly the exporter too when it's sending things out, or would you think that they're passing around the context and already handling all that stuff for you?
So in here, so if we look at this line, this tracer inject, this is just some code candy given to us by the open tracing package within Go. So it's saying, you know, we're injecting something into something. So we have our, if we look at I don't know how easily you can read this here, but if we're looking at the signature of the inject function, you're going to pass in some span context. There's what format are you injecting it as? For this, we're doing HTTP headers. And then the carrier is the thing that you're injecting it to. So this is just syntactic sugar, so that because most of the time you're going to be doing this for HTTP requests. So that's why they gave this to us, right? They made that for us. So even though we are using open tracing and everything else, we still have to tell it to do this. It's not going to just know to do it on its own. there isn't some background magic. And like I said before, we can extract the text map data of the tracer and pass that into some body being sent over to Kafka or to HornetMQ or to whatever other thing that we're using to pass this data through. You would still need to inject that at some point. Does that, I think I'm answering your question?
Yes, that answers just about all of it. Also, cool. So it's passing on the context when it's trying to use the carriers to pass the spans around. Curious, when you're creating the spans in one of the other services, if you're also passing around the context?
So this isn't Go context. This isn't context.context. This is the span context. Yeah. So they're not. Yeah. So it's.
This is like a config file. I got you. Okay.
Yeah. It's the data, so that when it sends that, when it finishes a span and it sends it back to Jaeger, it knows what to attribute it to. So when it actually gets to the payment service, it's been given that tracer packet and it knows, okay, I send this along to Jaeger, and then now Jaeger knows, oh, okay, I group this in with these other spans that are occurring with this whole trace that's occurring. Yeah.
Got it. It's configuration for that specific service that we're passing around. Cool.
Yeah. Thank you. Yeah, for sure. And then somebody asked, so I don't know OpenTelemetry too well, so maybe you can answer this for Bill. He's asking, is OpenTelemetry a superset of Jaeger, Datadog, etc., those clients, or does it require a new OpenTelemetry client? Do you know?
Yeah, basically, I'm just wondering about the 10,000-foot view, the ecosystem.
Yes.
Because I know OpenTelemetry is supposed to incorporate OpenTracing and like the metrics and the logs. But I guess the question is, you're using the Jaeger client here, and I guess there's a Datadog client, and there's a lot of other languages clients. So right now, do the OpenTracing clients work on, as part of OpenTelemetry, or is that requiring some new code because the protocols shifted slightly or something?
I can answer that question.
Actually, okay. Yeah.
Go ahead, Michael. You want to go ahead?
Yeah. So the important part when we're initializing our tracer here, we're telling it. I think it's happening up above. Okay, so actually, I didn't put this into the configuration just because I'm using purely the defaults. But in the configuration, I forget exactly which one it is. I think it's part of like the reporter object. Anyway, you're going to configure it and tell it that you're using the Jaeger client. And that's what I was saying early on, is you can have different clients for different levels. So because Jaeger is so simple to set up, like it's literally like a Docker, like I'm just using like an all-in-one Docker container. This is purely meant for local development. They probably even say somewhere on there, like, don't use this in production. But it's there for like my situation where I'm doing this local development stuff. But what you can also have is just a simple check, like is prod, or even a more specific flag, use Jaeger or use Datadog for production. So then at that point in your configuration, because I'm using just default Jaeger configuration stuff here. Actually, yeah, it's probably because I'm using Jaeger config that it knows I'm going to be using all these Jaeger defaults. And then that config, we're passing it in, we're creating a tracer interface. So it's adhering to the OpenTracing tracer interface, and that's what's getting passed up. So you can do different things at different levels or whatever, kind of pick and choose. Yeah. Does that answer your question?
Well, I guess it would be like, so Jaeger is not only the client, but it's also the service that supports the accumulation of the traces. If that's the case, then I guess my question would be more along the lines of, because OpenTelemetry is like this new thing, right? It's like in beta, it's a superset. And so I'm just not quite certain about, like, when people talk about OpenTracing versus OpenTelemetry, is Jaeger also an OpenTelemetry service, like full-fledged, or is it some sort of subtle differences where, in order to support like metrics and logs and some of this other stuff, you can't actually use the exact same clients anymore, or Jaeger itself is not really like OpenTelemetry?
Michael, you want me to feel this one, or do you want to take it?
Yeah, go for it. Yeah, you know
Okay,
more
cool.
about the open telemetry part of it.
Yeah, I just got into OpenTelemetry in the last like month and a half and whatnot. So did some reading on it. So OpenTelemetry is a merger between OpenTracing and OpenCensus, right? So they're trying to figure out what is the API, how do you actually access these services? And OpenTracing is perfect for doing all this other stuff. And they wanted to figure out who's actually going to implement this. What vendor do we use for this? So Google had this concept of OpenCensus, which worked really well. The two of them merged together, and now you have OpenTelemetry. So you have a choice when you pick up OpenTelemetry of picking which API you want and which SDK you want. By default, you would get the OpenTracing for the API and OpenCensus as your SDK. But it's really simple to plug in any SDK that you want. If you want Jaeger, if you want Datadog, Zipkin, anything else, they make it really easy. It's almost plug and play, similar to the way that Michael is showing you here. So hopefully that answers your question.
Yeah, thanks.
Yeah, you know, I think I missed the part when you were going over part of the code where there was sleep there. Would you be able to kind of go over a little bit, like, because sleep kind of introduced in my head is, you know, built-in latency. So where does the sleep happens? Is that, you know, within the processing of the message? Like you are, you know, and what I mean, what's the idea behind it?
Yeah, so I'm just using it to like simulate stuff happening. I'm not using it like it's like don't ever use sleep when you can avoid it. I really just have it here to simulate some action happening, whether it's an insert to the database or a call to some other API, whatever it is. So in here, this is that user create endpoint. That's the one that calls, you know, both notify and create account. So now if we go and look over at, you know, the notify handler, in here, I have another sleep, right? So it's something that takes between 0 and, actually, I think it's 1 and 50 milliseconds, 0 to 50 milliseconds. Anyway, some random small amount of time so that our spans actually take up some space. So if we were to take out this sleep here, all we would see is the time it took to log some key value pair. And that's what's happening to that notification ID, which is super, super short. I think that would be like on microsecond measurement. So these sleeps are just here for demo's sake, so that I can have pretty graphs to show you guys.
Okay, all right. I that's the part I forgot. I mean, I didn't catch when you were kind of going over it. So okay, got it.
Yeah, no worries. Yeah, it would scare me if somebody was giving a demo of like how to use OpenTracing, and then they're like, "Yeah, you got to have this sleep in here." Like it's just like, no, run away. Right. Yeah, that'd be really bad. Don't do that. But yeah, thank you for asking for clarification. That's good.
Any other questions? Okay. Oh, Michael, thank you so much for taking your time to come and share with us tonight. Obviously, a great topic and definitely one with a lot of interest for sure. So just really appreciate that and really appreciate you, man.
Yeah, thank you for having me.
Thanks for everything you're doing out in West LA.
Yeah, thanks.
For the Go community, especially. Let's see here. A couple things. The JetBrains, the good news, well, there's good news. The good news is 3 people entered. And I closed it out and have already determined that those 3 people will all get a license. I have an extra license from last month. So all 3 of you who entered will receive a JetBrains license. So awesome. And we'll be giving them away next month as well. So feel free to join then if you'd like one. I'm going to leave the Google Pixel raffle up until about 9 p.m. So if you want to do that, you can certainly jump in. I'll drop this in the chat one more time. And really excited about next month, and would love to hear from anybody that would like to share some talks going into 2021. I don't know when this is all going to end in terms of the, COVID and everything of that sort. But at the same time, just really looking forward to at least seeing what we can bring together virtually and have it as interactive as possible. So thanks for doing that, everybody. Anyone have any thoughts? Any conferences that anybody knows coming up? Gray, we got contacted about a conference today, didn't we? Did you get the information to send out to everyone or not yet? You're on mute, Gray.
Yeah, I think Developer Week sent us something. They've got something that they wanted us to send out. So when I get it from them, I'll mail it out.
Sure, and they also have if you go to Developer Week's site, they do have an open pass available for free that you can sign up for. I did request to see if they had any pro passes that they would share with us, because I think it entitles some people to some workshops. We'll send those out. If we do get those, we'll send those out first come, first serve to anybody that would like that. But anybody else have? And for those of you who did, the three of you that entered the JetBrains contest, and that is, just so I can make that clear, is Zachary, Steven, and Serge. Could you just send me an email to Ari at rew@jfrog.com? I check that one the most, and I will because Meetup doesn't always give us your email addresses. Actually, they don't give us your email addresses, so I'll just go ahead and send out those, and I'll send you out the JetBrains licenses in the next 24 hours or sooner for that. And for those who wanted the socks that ask questions, Bill, Matthew, Mohammed, and Alex, you can do the same. Sock color and address, promise you won't be in a database. And that is where we be. Yep, that's correct, Zachary, rew@jfrog.com. Any questions, comments?
Just to throw out on the OpenTracing talk, I'm linking my the GitHub page for the code that I was working off of. So if anybody wants to continue tinkering to build off whatever I've done, feel free to jump on that. Yeah. That's
great. And Michael, we like to put the talks up on our Meetup on our YouTube channel as well. Are you good with all that?
Yeah, absolutely, of course.
Okay. If anyone asks a question, we only do a speaker view. But if anyone asks a question and they absolutely positively do not want their question in the Q&A part on YouTube, just send me a quick note, and I'll make sure that you're not there. But I think the Q&A was as important as the talk this evening. But if you really don't want it there, I'm certainly not going to want to put it out there on YouTube. So we'll get that out there hopefully within the next couple of days as well. But hope to see everybody next month, unless anyone has anything else. For Natalie, we'll probably expand that, because I think that we should get a pretty decent attendance there, and looking forward to going into 2021. Anyone has any other comments before we close out? Next time I'll close with music, so not tonight though. All right, awesome. Well, I'll hang out for just a moment, and thanks everyone for coming tonight. It was great to see everyone.
Thank you.
Hey, thanks again, Michael.
Hi everyone, thanks for having me.
Hey, Michael. Oh, you're still here.
Yeah, sorry.
I just have a random question for you.
Yeah.
So I'm pretty familiar with using X-Ray with some Go microservices. But one of the things that really interests me about your talk and OpenTracing is just kind of the more cross-platform uses. We have the company I work at, we have a Apollo GraphQL server. And so is it reasonable to kind of expect that there's an OpenTracing library in kind of any language, at least Node? And
yeah, I'm sure, especially anything that has some amount of asynchronicity, I guess. So Node, there's some, asynchronous aspects to JavaScript where it's not necessarily happening in the background, but it can kind of do that, fake that for you. So I just hopped on the OpenTracing site. It looks like it actively supports Go, JavaScript, Java, Python, Ruby, PHP, Objective-C, C++, and C#. I'm
Nice.
sure there's unofficial packages for stuff. Actually, when I first started doing this, there wasn't an official Go package, Go client for Go, for OpenTracing, but there was like some beta level thing that somebody had made that was working pretty well. Because the OpenTracing interface, just for lack of better words, is really simple. It's just that idea of a span, the idea of a child, logging key value pairs, tagging key value pairs. So it's really, really simple. There isn't a whole lot happening to it. So it's not a difficult thing to implement on other languages.
Makes sense. Yeah. Yeah. That seems like, really one of the biggest benefits, I think, of going with something like OpenTracing is the cross-platform support or cross-language support, I guess.
Yeah, and like I was talking about earlier, there's the whole idea of the text map. So if something isn't an HTTP request, that's all you're passing through is you're getting the binary map or the text map, injecting that into whatever request as some additional parameter, extracting it, and then starting your new trace with that. So yeah, which is cool.
Okay, cool. Mm-hmm. Awesome.
I had a quick question, if you don't mind.
Yeah, absolutely.
I'm just kind of curious. Are you using Jaeger is that what you're using as your job or wherever you're running it?
For what we're doing is we have Datadog in production, and Datadog supports OpenTracing. It's just expensive to keep the data and to trace a ton of stuff. So that's why we're only doing a sample set of everything that's happening. Locally, it's Jaeger, it's local Jaeger. And then in our lower level environments, we have Jaeger set up for we have like our dev environment and maybe like our staging environment. Those are also using our own self-hosted version of Jaeger.
Okay.
So it's only
operating, that's been fine. I guess it's not in prod, so it doesn't matter too much. I guess that was my question. Is keeping the infrastructure been challenging, or the persistence complicated, or anything like that?
That would be an amazing question for our DevOps team.
Yeah,
I don't. Occasionally there's hiccups, like with everything, but I think that's just them tinkering. It's not that Jaeger is falling over on its own. Yeah.
Cool. No, thank you again for the talk. It was great.
Yeah, absolutely, man. Yeah. Cool. Yeah. All right. Well, I'm gonna head out for the night. Thanks again, Ari, for having me. That was awesome.
It was great. It was great having you. How's are you kicking things off again for 2021? You think, or are you gonna hold off a little bit?
I need to. So my life got additionally crazy during the pandemic because I just had a kid. So like throwing that in with pandemic level weirdness and just all that stuff, it's just been tough for me to schedule something.
Sure. Congratulations. That's awesome.
Yeah. Thank you. Yeah.
Little boy, little girl.
Yeah. A boy. His name is Luke.
First?
First kid. Yeah. First kid.
Named after Skywalker, Luke Skywalker?
What's funny is I had no real opinion on the name. That was my wife. She was the one that's like, I've always wanted to have a kid named Lucas. I really like the name. And I was like, hey, I get to, have a kid and tell him, Luke, I am your father. And it wasn't even my idea. Like, that's awesome. Amazing. I'll take it. Yeah, I'm not even going to argue with that. Yeah.
That's awesome. I have, I think if I told you this would be the best, but I actually have 7 kids. And I have one of those I am your father t-shirts, because chances are if you've seen me in the last 6 months, I probably am your father. So maybe saw me in person. So
that's cool. But yeah, I'm hoping 2021 I can get serious about it again and really dive into it. But I feel like most meetups kind of took a dive. Like it's really cool that you're pushing on, which is awesome. I would love to do that with the LA meetup. I might try to squeeze one in before the end of the year. But we'll see. Yeah.
And at the New York community, it's a great community, and I definitely want to see it see it be active, and then hopefully get back into a good role. As soon as we get past this thing. But one thing that we may be able to offer next year, we're working on a workshop for DevOps for Go developers. Nice. So that might be something that we can help you incorporate too, if that's something you're interested in. We're putting that together. We're going to be presenting it, I think, at GopherCon Israel. We're going to be submitting it there. Hopefully we'll be delivering it there. and then maybe rolling it out for people who maybe haven't gotten into the DevOps side of Go yet. But
yeah, that sounds awesome. Yeah,
very cool.
Definitely. Yeah.
Well, awesome. Well, thanks again. And thanks again, everybody. I'm going to go ahead and shut down, and looking forward to seeing everyone next month. Take care. Bye-bye.
Yep. Thanks, guys. Bye.